Hello, grade 10. How are you today? Hope you are fine. So in this video, I'm gonna focus more on some calculations, okay? But don't freak out, it's not a big deal. I'm gonna show you how to do some simple calculation regarding the electrical charts, okay? Because you have some exercise in your book that you might not know how to do it, so I'm gonna explain here with some examples, okay? So also in this video I'm explaining about the same topic in the same chapter, electricity and magnetism, but I'm gonna focus now about electrical charges and how do we calculate the charges and everything. Okay, so let's go. So as you remember in the previous presentation, electrical charge is the property of protons and electrons. And where are they? In the atom, right? So protons, where are they? Are they in the atoms? In the nucleus. And the electrons in the electrosphere. And what are their charge? So protons are positive charge. Electrons, negative charge. Neutron, no charge at all. And what's the charge of the nucleus? So the nucleus are positive. Why nucleus are positive? Because what do I have in nucleus? Protons and neutrons. Because neutrons doesn't have any charge at all, the only charge that influences the charge of nucleus is the protons. That's why I say the nucleus has positive charge, okay? Because it has protons that are positive. So now we are going to talk not just about one single atom, but like a body which is full of electrons and protons, okay? They can be positively charged or negatively charged or neutral, it depends. When I say a body is negatively charged, what they need to have most? They need to have more negative charge, right? Which particle has negative charge? The electrons. So it means for a body to be negatively charged, it must have more electrons than protons. What about a body that is positively charged? What it must have? It must have more protons than electrons. Okay, so it must have more positive charge than negative charge. And when do I say I have an uncharged body, or a body that has no charge at all? Doesn't mean it doesn't have charge, but it means that the charge are equal. So the number of electrons, that is negative charge, is the same as the number of protons. So when I have the same number of electrons with the same number of protons, I say that body is uncharged. So let's do an example. For example, for sodium. Sodium, if you look in the periodic table, you're gonna find this atomic number, so 11. And what does that mean? Remember? So atomic number tells me the number of protons. So here, where do I find the protons? In the nucleus, right? So my protons is in the nucleus. If I have 11 protons here in the nucleus, and from a periodic table, I'm not gonna talk about charged body, but uncharged. So let's say this atom is neutral. What does that mean? If I have 11 protons, I also have 11 neutrons. So let's count here, for example. Here I'm represent 1, 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So I have 10 in total for now, and I have one more here, so 11. Okay, I'm just represent this with a different color because it's gonna lose this electron. Okay, but it's electron in the same way. So in this representation, I have how many protons? 11. How many electrons that I count? Also 11. So my protons is the same number as my electrons. So this body is negatively charged, positively charged, or uncharged? It is uncharged, right? Because it has the same number of positive and negative charge. But what happens if I lose this electron? Remember from chemistry that we are studying, this is unstable, right? So for this atom, it doesn't like to be like that. It doesn't like to have just one electron in the last shell. So it is gonna lose this electron, right? To have 8 electrons in the next shell, then it's gonna be stable. Remember, the atoms looks to have 8 electrons in the last shell to be stable. Okay, so he's gonna lose this electron, so I'm gonna represent here the same atom, the same sodium, but now it lost this charge, this yellow charge. What's gonna happen now? How many protons do I have here? I have 11 protons, right? Did I change anything in the nucleus? No, I didn't change anything at all. So I just lost one electron. So my nucleus is the same. So I continue having 11 protons. But what happens to my electrons now? So let's count. I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So I have 10 electrons. So 2 plus 8, 10 electrons. What do I have more? More protons or more electrons? More protons. If I have more protons, I have more positive charge or more negative charge? I have more positive charge. So I say this atom is positively charged. How do I represent them? For the first one, that I have no charge at all, I just represent like here, like just the symbol of the atom with no charge at all. But in this case, what happened? It is more positive, so it's positively charged. So I'm going to represent it with a positive signal because it's positively charged. Why it's positively charged? Because it has more protons than electrons. Okay, is that clear? Okay, I hope so. So if it's not clear, please tell me, okay? I'm going to do another example. So here I have the same, negatively charged, more electrons than protons, positive charge, more protons than electrons, and uncharged, the same number. Let's do the same for chlorine. So I have 17 here. What does 17 means? I have what? 17 what? I have 17 protons. So I'm gonna put here 17 protons, right? And how many electrons do I have? Also 17. So 2 here in the first shell. Remember, just 2 in the first shell. 1, 2, 3, 4, 5, 6, 7, 8 in the second shell, so 10 in total. In the third one, 1, 2, 3, 4, 5, 6, and 7. So I have 7 in the last shell. So in total I have 17. Okay, let's count. So protons, how many do I have? 17. How many electrons? Also 17. So what is the charge of this body? Negative, positive, or uncharged? The proton is the same as the number of electrons, so it is uncharged, right? Okay, but it's not stable. Why? Because it has 7 electrons in the last shell. The atom likes to have 7? No. So he wants to have how many? 8. What's easier to happen here for this atom? To lose all the 7 atoms or to get one to have 8? What's easier? It's easier to have one more, right? So it's easier to get one than to lose 7. So I'm gonna represent here this atom. Now it got one electron. Where this electron came from? Remember the sodium? So they're the perfect pair because the sodium wants to lose one and the chlorine wants to get one. So they're the perfect pair. What they formed? The salt, chlorine salt, sodium chlorine. Okay, so now it gets 1. Is there something that changed in the nucleus? No. I didn't change anything at all in the nucleus. So how many protons do I have now? I continue to have 17. I didn't lose any protons. I just got electrons. I didn't lose any protons. But now, what happens to my electrons? I had 17 before, and I got 1. So how many electrons do I have now? 18, right? What do I have more? Protons or electrons? Now I have more electrons. So if I have more electrons, what's going to be my charge? So I have more electrons. What's going to be my charge? Negative or positive? Negative, right? Why? Because electrons has negative charge. So I have more negative charge than positive charge. So this body now is negatively charged. And how do I represent? For the chlorine, for the uncharged chlorine, I just represent with the chlorine symbol. But what happens here? It got 1 electron and is negatively charged. So I represent the chlorine, but with a negative sign, meaning that I got 1 negative charge extra, 1 negative electron. Now it has 8 electrons in the last shell. Now it's good. It's stable. Doesn't want many more. It's already what he wants. Okay, is that clear so far? Okay, if it's not, please send me a message, okay? And then I'm gonna help you more about this. Okay, for now I'm gonna move on. Let's do some examples together. For example, this one. Identify the following particles as being charged or uncharged. If charged indicates whether they are charged positively or negatively. So the representative is N for neutron, P for proton, and E for electron. In the first example, so the particle A. Here, let's make a list. As in the exercise, it means P is for proton, N is for neutron, and E is for electron. Let's make a list. How many protons do I have here in this diagram, particle A? I have 9, right? So I have 9 protons. And how many electrons? So I have 2 electrons in the first shell and 8 in the second shell. So how many electrons? 2 plus 8, 10, right? Okay, now what do I have more? More electrons or more protons? More electrons. So I have more electrons than protons. So I'm gonna be uncharged, positively charged or negatively charged? I'm gonna be negatively charged. Okay, so every time I have more electrons, I'm negatively charged. Now, the second example. The same way, let's make a list. How many protons do I have? How many protons is represented here? It says, for me, 11 protons, right? So 11 protons. How many electrons do I have? So 2 in the first shell, 8 in the second one, and 1 in the third one. So 2 plus 8 plus 1, I have 11 electrons, right? What do I have more? Protons or electrons? I have the same. So electrons is equals to protons. So this atom here is positively, negatively, or uncharged at all? It is uncharged because I don't have more positive or negative. They are the same. So they are uncharged. Okay, next one. C. How many protons do I have? 20. How many electrons do I have? Say loudly. Let your mom and daddy think you are crazy. That's okay. Answer to me. How many electrons? 2 plus 8 plus 8. So 2 plus 8, 10 plus 8, 18, right? What do I have more? Protons or electrons? I have more protons. So what is going to be the charge? Positively charged, negatively charged, or uncharged? Positively charged, right? So if I have more protons, I have more positive. charge than negative one. Okay, now I have a question. Why I didn't count the neutrons? Why I didn't even look to the neutrons to do this exercise? Why? Because neutrons has no charge at all. Why am I gonna count the neutrons? Because I'm not looking for the number of neutrons. I'm looking just for the charge of this atom, of this particle. If this particle has, if the neutrons has no charge at all, there is no purpose for me to look to the neutrons. Okay, so to do this kind of exercise about charge, you don't need to worry about neutrons. Just ignore them. Okay, even though the exercise gives the information, you don't need it. Okay, why? Because neutron has no charge at all, so has no influence in the charge of the particle. Okay? Okay, so let's go to the next example. So example 2. Consider the graph at the right of a neutron oxygen atom. So here I have a representation of an atom of oxygen atom. From the exercise, how many protons do I have? Where is the proton? The nucleus, right? So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 protons here in the nucleus. I have 8 protons. And how many electrons? Count for me. 1, 2, 3, 4, 5, 6, 7, 8 as well. So I have 8 electrons as well. Okay? What can you say about this, the charge of this one? The protons is the same number of electrons, so it is uncharged. Okay, we just analyzed the picture. Let's see the questions now. Explain what must happen for the oxygen atom to become negatively charged. So here in my diagram, it's uncharged. But what needs to happen for it to be negatively charged? What needs to happen to be negatively charged? It needs to get or to lose electrons. Remember, I just look for the electrons because I cannot change the nucleus. When I change the nucleus, it's another story. I'm talking about nuclear bomb. It's another story, okay? We're going to focus only in electrosphere when we talk about electricity. Okay, so what needs to happen here for my atom to be negatively charged? I need to get electrons. I need to get more negative charge, right? So I need to gain electrons. If I gain electrons, I have more electrons than protons. So I'm gonna be negatively charged. Okay? Is that easy? Yes, right? Next one. Explain what must happen for the oxygen atom to become positively charged. Now it's the opposite. And I have a question. For me to be positive, can I get protons? No, not when we are talking about electricity. When I change nucleus, as I said, it's another story, okay? I'm gonna talk about nuclear energy. It's a completely different story because nucleus are very stable. So for me to change anything in the nucleus, I must have a huge energy to do that, okay? So here, let's talk just about electrons. So I'm gonna gain or lose electrons. So for me to be positively charged, what needs to happen? I need to lose electrons, right? If I lose electrons, my number of protons will be more than my number of electrons. So my number of protons will be higher than my number of electrons. If my number of protons is higher than my number of electrons, it's gonna be positively charged. Okay, so when I ask you about what needs to happen, don't say to me he needs to get protons. No, this doesn't happen. Okay, we are not talking about nuclear energy. We're talking just about electrosphere. Okay, so just think about electrons. Just think about electrons receiving or losing. So if I want to be negatively charged, I need to receive electrons. If I want to be positively charged, I need to lose electrons. And that's it. Don't change the number of protons ever. Okay? Okay, next example. Determine the quantity and type of charge of an object that has 3.62 times 10 to the power 12 more protons than electrons. So I have more protons than electrons. Now we need to remember one concept from before, okay? So here I have more protons than electrons. How many protons do I have? How many? So it's given here. I have 3.62 times 10 to the power 12. I don't know how much, but I know I have this more than electrons, okay? And this is enough for me to calculate the charge. And from before, the charge of one proton or one electron is 1.602 times 10 to the power minus 16 coulomb. Okay, so this is from the previous presentation. The charge of one proton or one electron is always this charge. And here I have 3.62 times 10 to the power 12 protons. How do I calculate the total charge? If it's one proton has 1.602 times 10 to the power minus 19, what's going to be the charge of 3.62 times 10 to the power 12 protons? What's going to be the total charge? What do I need to do here? Just a multiplication, right? So the total charge is going to be the charge of one proton times the charge times the number of protons that I have. Okay, so this is math now. You just should do this. Please calculate just 1.602 times 3.62 and get a number. And after, you just calculate the 10, okay? So 1.602 times 3.62 is 5.78, right? Now, how do I calculate the 10? Remember, if I have the same base here, I just keep the base, and if I'm doing multiplication, I add the exponent. So minus 19 plus 12, what do I get? Minus 19 plus 12, I get minus 7. So my total charge of all these protons that I have extra is 5.78 times 10 to the power of minus 7 coulomb. So how do I get now? Because there is more proton than electrons, the charge will be positive because I have more protons than electrons. And how do I answer? I have my charge 5.78 times 10 to the power of 10 minus 7, but there is one more information that you need to add. You need to put the signal. If my charge will be positive, I put a positive sign here. If my charge is negative, I put a negative here. Okay, so in this case it's positive. I put one positive. Okay, are you awake over there? Understood? Okay, let's do one more. I guess it's gonna be more clear. So after charge an object, we calculate it has lost 3.10 to the power of 9 electrons. So it lost 3.10 to the power of 9 electrons. The resulted charge is positive or negative? Negative. Why? If I lost electrons, what's gonna happen? I lost electrons, I lost negative charge. If I lost negative charge, I have more positive than negative, right? So if it lost electron, it has more protons than electrons. So I have more protons than electrons. If I have more protons than electrons, it's negative or positive? Gonna be positively charged. Okay? So, answer to this question. The resulted charge is positive or negative? Why? It's positively charged. Why? Because I have more protons than electrons, since I lost electrons. Okay? Easy? Okay. Now let's go do some math. What is its charge in coulomb? So I know that one proton or one electron has 1.602 times 10 to the power of 19 coulombs. So just one proton or one electron has the charge. But here, how many do I have? I lost 3.3 times 10 to the power of 9 electrons. It means I have 3 times 10 to the power of 9 protons extra. Okay, so I have 3 times 10 to the power of 9 protons extra since I lost electrons. And what is going to be the charge of this one? So I just calculate the times. 1.602 times 10 to the power of 19 times 3 times 10 to the power of 9. So first do 1.602 times 3. I'm gonna get 4.81. After that, look to the 10. So 10 here, 10 here. If it's a multiplication, keep the 10 and minus 19. Minus 19 plus 9, what do I have? Minus 10, right? This is just math. So this is the charge of my object now. Because there is more protons than electron, it's going to be positive or negative. So I have more protons than electrons, so it's going to be positive. How much positive? What I just calculate. 4.81 times 10 to the power of minus 10 coulombs. Now, the most important part. The charge will be positive, so I need to put a positive sign here. Okay? Okay, so breathe, it's the last one. After charge an object, we calculate it has gained 4.5 times 10 to the power of 5 electrons. So now I receive the electrons. If I receive electrons, what should come in your mind? I'm going to be more negative or positive? I'm going to be more negative, right? So the resultant charge is positive or negative. Why? So since I receive electrons, I have more electrons than protons. So my number of electrons will be higher than my number of protons. So I'm going to be negative charge because my electrons is higher than protons. Okay? Okay, the second one. What is its charge in coulombs? So now let's calculate the charge of this. If I have just one proton, I know it's 1.602 times 10 to the power of 9 minus 19, okay? So this is given for you, don't need to memorize. But now I have 4.5 times 10 to the power of 5, electrons or protons, doesn't matter, okay? So how much do I have in coulombs now? I have 1.602 times 10 to the power of 19 times 4.5 times 10 to the power of 5, okay? So first, the number 1.602 times 4.5. So I get 7.21, if you can check, okay? Now for the 10. So 10, the same base, 10, the same base here. So I keep the 10. And what do I have to my charge? So I have minus 19 and 5. Minus 19 plus 5, I get minus 14. Okay, so this is my final charge. Because there is more electrons than protons, my charge will be negative, right? So the number that I got there from the calculation, which signal do I need to put before? Positive or negative? Negative. So the number I've got, I need to put the negative sign first. Okay, why? Because it will be negative. Okay, it's going to be negatively charged, so I need to put the minus over there. Okay, guys, I know it's a little bit hard, but Please watch again if it's not clear. If it's still not clear, please send me an email, okay? Tell me what are you struggling with and ask me questions, and I can prepare another explanation about this for you if it's still not clear, okay? If it's clear, please try to do the exercise and also the exercise from your book now, okay? Thank you so much for your patience and for your persistence of study, okay? Please be safe. Bye-bye.